Besides factoring to solve quadratic equations, which I like best because if the equation will factor, it seems like that's the most efficient way. But there are other approaches, and one is to use what we call the square root property. So if we have a quadratic equation in the form x squared equals k, where k is a positive number greater than or equal to 0, then we can use this property to solve for x by taking the square root of both sides. Now I don't have all the steps down, but I would like to write out that if I take the square root of x squared and I take the square root of k, the square root of x squared is not x, it's the absolute value of x. And the absolute value of x is equal to the square root of k means that x is equal to the square root of k, or to its opposite, and that's where it picks up the plus or minus. And that's where this comes into play. So I'm going to use that property to solve these two equations. They're very similar equations, even though they look a little bit different, in that they have the variable expression squared, and here they have an expression with the variable and it's squared, and the constant on the right side by itself. So once it's looking in that form, I might have to even rearrange it a little bit, but once it's in this form, then I can use the square root property, the square root of a squared, and the square root of 49. Alright, so I'm going to take the square root of a squared, which I was just talking about is the absolute value of a. That's supposed to be an a there, not too good. And over here, of course, the square root of 49, that was convenient, that's 7. So that means that the absolute value of a is 7, implies that a is either equal to 7 or it's equal to the opposite of 7. So I'll write that as plus or minus 7, and that's my solution. Now if they ask, again, because these are equations, if they ask for a solution set, don't forget to use the braces. So for right now, I'm going to probably just write out my solutions this way, but you will see in the textbook especially, they like to write it out as a solution set. They may not even write it with the plus or minus. They might write it as negative 7, 7 like this. Okay? But it all depends on the directions. You're fine here if it doesn't ask for the solution set specifically. Now over here, I have the expression on the left side, and it has the x plus 4, the expression with the variable that's squared. I'm going to take the square root. I have to undo that square by square rooting it, although that's not really a verb. And I take the square root of both sides. Now the square root of 24 doesn't come out evenly, but that's okay. And I'm not going to grab a calculator and approximate it. I am going to simplify that radical. Now here, when you take the square root of this expression squared, I get the absolute value of x plus 4 is equal to the square root of 24. Because 24 is 4 times 6 and 4 is a perfect square, I can write that as 2 square roots of 6. Now I'm going to drop the absolute value bars here, which means I'm going to pick up the plus or minus as so. Now one extra step, the variable is not isolated. I have to get the variable x all by itself. I'm going to subtract 4 from both sides. Now notice here, I put it on the right end here. But over on this side, I'm going to stick the minus 4 as a negative 4 out in front. It's just more convenient to write it this way. And I get my two answers, negative 4 plus or minus 2 square roots of 6. And again, two answers, it's quadratic. Negative 4 plus 2 square roots of 6, negative 4 minus 2 square roots of 6. This is convenient, but this is really only when the problem is set up so that you can take the square root of both sides. You have that variable in an expression where it's squared. Now over here, we're going to use a little trick called completing the square to solve the equation. Now, this is probably the method that I use the least, although it is very important because it derives the quadratic formula, which I'm coming up to. But when you complete the square, the idea is to get the trinomial to be a perfect square trinomial. This guy right here, he's a perfect square trinomial. I can tell that. I have the first term is a perfect square, it's x times x, I'll put a little x here. The last term is a perfect square, it's 5 times 5. I have a plus sign in front of the 25 because if I'm squaring something, it's got to come out positive here on the end when I do the L and FOIL. And then, if I take the product of what's being squared in the first and the last terms, 5 times x is 5x, and if I double that, do I get the middle term? Yeah, this is 2 times 5x. Now, don't worry about the sign. I'll take care of that in just a second. But if you have those four things match up, notice that I can write it as a binomial squared. The first term in the binomial is what was being squared in the first term of the trinomial. The second term in the binomial is what was being squared in the last term of the trinomial. And the sign in the middle is the same as the sign in front of the middle term. Minus sign here, plus sign here, plus sign here. And if you take x minus 5 and square it, x minus 5 times x minus 5, you can do FOIL, or you can remember the pattern that we studied just recently, then you will see that you'll get right back to where we started. Same thing here. This is 3z times 3z. This is 2 times 2, that's a plus sign. If I take the product of 3z and 2 and double it, I will get 12z, and that matches up nicely. Notice plus sign here, plus sign here. The 3z, the 2, the plus sign, quantity squared. Now I can use that approach when I am solving an equation by completing the square. So what I prefer to do when I'm completing the square is I prefer my coefficient of my x squared term, and you can see I have this quadratic equation in standard form all nicely set up. I'm not going to try to factor it or anything. I don't even know if it factors. I haven't tried it. So what I'm going to do here is I am going to complete the square. I want the two terms that contain the variable isolated, which means I've got to get rid of the minus 6. So I'm going to start off by adding 6 to both sides. You'll see why I want it isolated in a second. I have 3x squared minus 24x is equal to positive 6. All right, because I want to complete the square here, I don't want the 6 in my way. I want to be able to add a number right here to set it up to make this a perfect square trinomial. But before I do that, I want my coefficient of my x squared, whatever my variable is squared, I want it to be a 1, and right now it's a 3. So I will divide through by whatever that number is, every term, both sides. And conveniently for us, 3 goes into all those coefficients nicely. These cancel out. I get x squared minus, looks like 8x. And I'm going to leave a space. You'll see why in a second. And I'll put the 6 divided by 3, which is 2. This is the part where I'm completing the square. I left a blank here because I want to add a number to make this a perfect square trinomial. Here's the trick. If my lead coefficient's a 1, I take the coefficient of the x term, or y or z, the linear term. It's a minus 8 or negative 8. You take half of negative 8, divided by 2, then you square it. 2 steps. You take half of this coefficient and then you square it. So negative 8 divided by 2 is negative 4, and negative 4 squared is positive 16. That's the number I need here to make this a perfect square trinomial. I need to add 16 here, and of course, since it's an equation, I'll add 16 to the other side. This guy is a perfect square trinomial. I can rewrite it as a binomial squared. Over here I have 18. This is a perfect square, x times x is a perfect square, 4 times 4, that's a plus sign, and if I take double the product of what's being squared in the first and last terms, I get the 8x right there. So this is going to be an x, this is going to be a 4, and it's going to be a minus sign. Remember, if that's minus, then this is minus. If that's plus, then this is plus. If all the other 4 questions I ask myself come up with a yes answer. So now I can kind of do the square root property that I just did back here. I'm going to take the square root of both sides. I'm running out of space here, but I'm going to take the square root of both sides. This is going to give me the absolute value of x minus 4. This gives me the square root of 18, which does not come out evenly, but it does simplify, since 18 is 9 times 2. This is 3 times the square root of 2. I drop the absolute value bars, which means that the expression inside is equal to that, or its opposite, so I put plus or minus 3 square roots of 2. We're running out of space, but to get rid of the minus 4, kind of like I did back here, it was a plus 4 before, no pun intended, I'm going to add 4 to both sides. Remember, I added on the end on the right here on the left side, but on the right side, I like it out in front of the plus or minus, so I'll put the positive 4 there. And these, of course, cancel. X equals 4 plus or minus 3 square roots of 2. And those are my answers. So this definitely would not have factored, because you can see I have irrational answers. I have 2 answers, though. 4 plus 3 square roots of 2 and 4 minus 3 square roots of 2. Now, I don't want to take the time right now, even though I probably should, to derive the quadratic formula. I'm hoping that your Algebra 2 teacher has shown you this. It is in the textbook as well. But from completing the square, we can take this equation and we can solve for x, and we get this guy right here. Now, I was just helping a student not that long ago with the quadratic equation to solve, and I asked her, I said, do you remember the quadratic formula? And I wrote it out. And she looked at me, no, I don't. That's one of those formulas you need to memorize. You see it in Algebra 1, you definitely see it again in Algebra 2. There's all different ways to memorize it. There's a little song with Pop Goes the Weasel, the melody of that, but you need to have this memorized. Now I'm going to use this to solve any quadratic equation I want. I typically only use this when my factoring process doesn't work, but this is always something you can fall back on. It'll work for the equations that factor and the ones that don't. And it's a little faster than going through all these steps because it's kind of already done all that to get to here. We're just going to plug in values. The A, the B, and the C right into the formula. The 2 and the 4 are part of the formula all the time. But you have to have it in standard form, and my example here is not in standard form. I am going to distribute. I'm going to get x squared minus 8x is equal to 3. I am going to subtract 3 from both sides, and now I have it in standard form. So now I'm going to solve this by taking the coefficients, the a, the b, and the c, the constant term, and substituting them into my formula. Now there's no number in front of the x squared, but that's an understood 1, so a is 1. Here, I'll write it over here. A is 1, b is negative 8, c is negative 3. If you're seeing this for the first time, you are definitely in over your head right now because this is something you should have seen before and should be familiar with. It's a good review though. So I'm going to plug into this formula. X is equal to the opposite of b. The opposite of negative 8 is a positive 8. Plus or minus the square root of b squared, so that is a negative 8 that gets squared, minus 4 times a, which is nice, it's 1, times c, which is negative 3. And that's all over 2 times a, so 2 times 1. Be careful with your arithmetic underneath the radical, especially with the signs. I'm going to write this as x equals 8 plus or minus the square root of, this is 64, minus 4 times 1 times negative 3 is negative 12. So this is going to be minus negative 12. Okay, and that's all over 2. When you subtract the negative, that's the same as adding the opposite. So that turns out to be 76, which I usually say that's the spirit. 76 all over 2. And now, I'm not going to stop here. I'm going to simplify this expression. And this expression is simplified. Now the 2 doesn't go into the 76, but 76 has a perfect square factor of 4. This is 4 times 19. So I'm going to rewrite this as 8 plus or minus the square root of 76, a little scratch work here, which is the square root of 4 times 19 is 2 square roots of 19. Now the 2 that's in the bottom, I can simplify by dividing, but I have to divide it into both terms. And since I have those nice even numbers there, I can do that kind of conveniently. I get x equals 2 goes into 8 4 times, plus or minus 2 goes into 2 square roots of 9, well 2 goes into 2, 1. So that's square root of 19. And those two guys are my answers. Very important formula to remember.